Hello, and welcome to Calculus. Today, we will be talking about the chain rule in terms of functions with three or more variables. Now, the reason why it's called the chain rule is because you'll be chained for, 18 years trying to figure out how to derive an equation using the chain rule. Anyways, I am sure you all remember your lower life form days in Calc 1 and Calc 2 where you used the chain rule to derive equations such as these. Well, now you have to derive equations such as these. Now, I know these look complicated to you simple-minded creatures, so I will make an analogy that will surely help you understand. Babies. Why babies, you ask? Well, they're annoying, they're hard to take care of, and you are chained to them for the next 18 years. Anywho, let's actually start learning how to derive functions with three or more variables. First, let's take a look at this chart, or a family tree if you will. You have the original equation, or in our case, the mother equation. In here, we extract the babies, x and y. In other words, we are deriving the equation in terms of x and y, giving us df over dx and df over dy. After that, we derive x and y in terms of t. We extract the babies from the babies. Babyception. You know, the less you think about this as a family tree, the better off you'll probably be. So, after all that, we should have an equation that looks like this, where we have the derivative of the function in terms of x times the derivative of x in terms of t, plus the derivative of the function in terms of y times the derivative of y in terms of t. Let's have an example. Here we have this equation, w equals 2x squared plus 2y squared, where x is equal to sine t and y is equal to cosine t. And we must find dw over dt. So first we must find all the parts we need to get the derivative, the baby parts. For dw over dx, we must derive w in terms of x. So here's the equation of w. To derive it with respect to x, we must treat all other variables as constant. That's right, baby y. I am taking care of baby x right now. You are unimportant. So after doing all that, we should get dw over dx is equal to 4x. After that, we will now work on dw over dy. See, baby y, now that I've finished taking care of your brother, it's your turn to have fun. So now instead of treating y as a constant, we treat x as a constant. Baby x is unimportant right now. So by deriving the equation with respect to y, we get dw over dy is equal to 4y. After finding dw over dx and dw over dy, we now need to find dx over dt and dy over dt. So we have the equations x is equal to sine t and y is equal to cosine t. And these equations are a lot easier to derive because there's only one variable. It's baby mode. So we should get dx over dt is equal to cosine t and dw over dt is equal to negative sine t. Now that we have all the parts we need, we can assemble dw over dt. After using the baby parts to assemble dw over dt, we should get dw over dt is equal to 4x cosine t minus 4y sine t. But wait, this is only supposed to be in terms of t. X and y shouldn't be there. Well, worry not, for we can replace x and y with their equations. So we should get dw over dt is equal to 4 sine t cosine t minus 4 cosine t sine t, which evaluates to 0. Congratulations, we have derived this equation using the chain rule. But what if we want more variables, more babies, like with this problem? Well, we just do the same thing, except now we have a third baby, another baby to add to the tree, and a longer equation. So let's get started on the problem. We have w is equal to e to the power of z plus ln x y plus x squared, where x is equal to t squared over 2, y is equal to 3t, and z is equal to ln t. First, we find dw over dx, dw over dy, and dw over dz. That means we derive w in terms of x, in terms of y, and in terms of z. Then we find the derivative of x, y, and z in terms of t. After that, we plug each one into the equation, replacing x, y, and z with their respective expressions. Now we have dw over dt. But what if t wants to be something? Baby t has dreams and aspirations to become a 1. So we plug in 1 for t in the equation and we get 5. So what have we learned today? Don't have babies, just take calculus.